In the previous videos, we talked about the most recent and freely available spaceborne LiDAR data from the NASA GEDI mission and so how to download it directly from the website. In this video, we'll be looking at how to read, visualize, and subset these massive chunks of data for our study area using the R programming software. The related R codes will be provided in the description section. And also towards the end of this video, I'll be showing you how to directly download the LiDAR data granule comprising your study area from R. So make sure to watch till the end of this video. Hey guys, welcome back to my channel. In case you are new here, hi there, this is Mikey. I'm a graduate student working in the remote sensing and forestry sector. In this channel, I'll be uploading videos every day on topics ranging from GIS to remote sensing to machine learning and everything else in between. So don't forget to hit that subscribe button. Okay, now let's get back to where we had left. We wrapped up the last video showing how to download the LiDAR data. If you guys remember, the file was in H5 format. Now let's move to the R programming platform and I shall show you how to read the H5 file and subset it. So we have primarily three main things to do today. So the first one is I'll be showing you how to subset a already downloaded LiDAR data. Then we'll be visualizing that subsetted LiDAR data, and also towards the end I'll be showing you how to determine the respective GEDI granule ID and download data directly using R. The R package we'll be using here is called rGEDI. This is a package my colleague Carlos Silva and his team developed recently, and it's very powerful, and I think it's the only one R package for analyzing GEDI data. Other than just subsetting data, you can also use this package for doing other things such as data visualization or gridding or even simulating airborne LiDAR data to act like GEDI data, and a lot of other things that we'll be covering in the upcoming videos. Here, since I already have installed the rGEDI package, I'm just gonna call it. While installing this package, if it's Mac, you might have to install some additional functionalities. So please let me know if you run into any roadblocks and I can try helping you with it. In this case, it's better to leave a comment so that it can be helpful to other users as well. We will also be installing and loading two other packages here for data visualization purposes, namely dplyr and leaflet. I have installed these packages as well before, so I'm just gonna call it. So the second step is to make sure that we assign a working directory. This directory should be the place where we have the H5 files that we had already downloaded, and I am also assigning the output directory to be the same, which means that the data which we subset will also be exported to this folder. I can show you this folder, my directory, which I just defined, so that you can see the kind of file which we have. So this is an H5 file that we'll be working with. This H5 file is actually a part of the rGEDI package, so you can use the same one. I'll be providing a link where you can directly download this sample data so that you can work alongside and test these codes. Here, for reading the H5 files, we'll be using the read level function. You just need to make small changes based on what level of GEDI data you're working on. So for example, here it's level 1B data, whereas here we are working on 2A and 2B. This is the path, so the output directory and also the files that we'll be calling. For this particular tutorial, I'll be just working on with the level 1B data. So run this code. Oh yeah, we need to first run these things. I'm assigning my working directory and also my output directory, and we will read the H5 file which I just showed you. So now we have read the file. If you just check out this variable, you can see that actually there are not a lot of information available here other than the name of the beam. If you remember, in my previous video I had mentioned what each beam represents, so in case if you wanna learn more about it, you can check out my previous videos, and I'll be including a link or like an info bar in the video here. But this is fine, we can extract other relevant information such as canopy height and canopy cover using various other functions, which I'll be showing you in the upcoming videos. For now, let's just get the geographical coordinates, and for that we'll be using the get level 1b geo function. So run this code, and if you check what are the columns we have here, we can see that now we have information on the short number, latitude, longitude, and also elevation data. Now for subsetting the data, let's first create a bounding box. Here the x coordinates represent the longitudes and the y coordinates represent the latitudes. The sample H5 file is for a study region in Brazil, and that's why all the values are negative, because it's located in the southern hemisphere and also towards the left side of the globe. Also from the previous codes, you notice that there are columns representing latitude and longitude values, right? So these latitude bin and longitude bin are the things we need. You can actually see what is the current extent of the sample data set we have got. So run these codes as well. So these are the bounding box values, and now we can subset some data based on the new coordinates that we have defined here. For subsetting the data, we use the clip level function. Here again, we are just doing it for level 1b, but it's very similar for level 2a as well as level 2b. So this is the data which we have got here, here, the data which we have read, and we define the xmin, xmax, ymin, ymax, and also the file path to the output directory, and we also define the name of the file here. So let's run that. Here our area is pretty small, so it won't take that much time, but in case if your study area is large, it might take few minutes, so just be patient. Now if you check the output folder, you can notice the new H5 file. So this is a clipped data. Now let's read it in R using the same codes that we used in the start. Also here note that you can't rewrite a H5 file here in case there are some errors during the first clipping operation. However, you can just change the output file name and create a new one. Now let's visualize the subset data using the leaflet package. We will be basically plotting the points which signify the GEDI footprints XY coordinates here. Let me know if any of these parameters here are a bit confusing. I think it's pretty self-explanatory, but please leave me a comment if you run into any issues. Here the red dots represent our clip area and the green points represent the mean data. And if you zoom in, you can get a better idea of the location. Also note that we gave like a bounding box, so that is like a rectangle, more like a square here. So that's why we have the red points only in those areas. It just takes the GEDI footprints which fall inside that particular rectangle. So that's it. Not really. You saw how to subset your data based on geographical coordinates here, but for performing this operation to narrow the GEDI footprints to your study area, you first need to make sure that you are performing these operations on GEDI granules that cover your study area. We can locate and download the corresponding GEDI granules either from the rGEDI website or directly through R. In case you are getting a bit confused regarding the terms such as the granules, I will include a info bar above so that you can check out my previous videos where I explain more on those terms. In my opinion, downloading from rGEDI might be a bit safer option, as there is a high chance that your R is gonna crash while handling this big amount of data. Either way, you will need to know the GEDI granule ID for downloading the data. So let's see how to find it. Again, there are multiple ways for doing this. Here we are already inside R, so I'll be showing you how to do this within R. In the upcoming video, however, I will show you how to locate the granule ID as well as perform the subsetting directly in the rGEDI platform without having to download the entire data like how we are doing here. I shall include a link to that video as well once it's up. Here we search for the granule that includes the bounding box that we had earlier defined. However, note that we will be downloading the entire granule here, and later we will have to bring it into R and subset it separately. We can also define a date range, though it's optional. However, take a note of the longitude, latitude order here, as you don't want to mess this up. Instead of level 1B data here, you can do the same for level 2A and level 2B as well. Now let's run this code. It might take some time. Oh, I think I actually didn't run the date range. So let's do that and try running this code again. So that's done. Now let's see the file. So here we have actually 2 GEDI granules for our study area for our particular time period. It's always nice to have more granules so that we will have more overlaps. Note that GEDI started collecting data from around March of 2019, but it doesn't mean that all the areas of the tropics will be having data for these times, especially if your study area, the bounding box is very small. In our case, we were lucky and we had 2 granules, but maybe some other areas won't be having this many. So in that case, just maybe remove the date range so that you can get all the data that was ever collected. And here, these information towards the end, this is what we actually need. This is the GEDI ID. If you copy paste it on the Earth data site, as I showed you in the last video, you can download the data directly there. But for now, let's just do this within R itself. For that, we can use the GEDI download function. And in this case, we will just try downloading the first granule. So run this code. Here, actually, they will ask you for your credentials for logging into Earth data. As mentioned in my previous video, for accessing the free LiDAR data, you will have to create an Earth data account. It's super easy, and I shall include a link to the main website in the description section so that it's easier for you. Also, the good thing is that, like you have seen, I had already logged in, so you just need to log in once, and for all the further data downloads, you don't have to enter your credentials again and again. Okay, this will take some time, but that's pretty much it. Once you download the granule H5 files, you can repeat the process and do the subsetting part again. But I recommend not trying to visualize the entire granule using the leaflet, because this will probably crash your R. I suggest you first check the maximum longitude and latitude of the granule and maybe create a subset which is a buffer of your exact study area, and then look at how many GEDI granule overlaps you have and confirm that's the area you really want. After that, you can narrow it down to your exact study plots, because it's always better to work with a smaller amount of data. For example, the green area here is already a subset of the real GEDI granule because it's so hard to visualize the entire granule. I also understand that in most of the cases, the study area is not a perfect rectangle that can be described by the bounding boxes. So I'll be making a tutorial video on how to extract the GEDI footprints based on your shapefile in a bit, and the video link will be provided here once the video is up. However, the rGEDI tutorial already has some examples in this regard. The link is included in the description. In case if you wanna get a head start, please feel free to check it out and leave me a comment if you run into any roadblocks. So let this keep downloading. SOS todo for now. Make sure to keep yourself updated on my LiDAR remote sensing playlist. The link will be provided in the description section. In the next video, I'll be showing another way to subset the data without having to download the entire granule. So stay tuned till next time. Ciao.